Today we're talking about our new Smart Switch, which is a 4-channel digital switching module that connects directly to a Victron servo. It works at 12 and 24 volts, and it will allow you to control lights, pumps, refrigeration directly from the touchscreen of a Victron servo setup. The unit has 4 channels, but if you need more, you can fit multiple units into your system. It will populate as separate pages on the Victron servo, which you can name, and then you can swipe between those pages to control the different devices. In this video, I'm going to concentrate purely on the connection arrangements for the unit. We're going to do a separate video talking about the functionality. The connections on the unit comprise of positive and negative input, positive and negative connections for 4 output channels, so 8 in total. And then we have 2 RJ45 connection ports, which is the method of communication to the Victron servo. So going through these in turn. So we'll start with the power supply. The unit can operate on 12 and 24 volt systems, so it has an 8 to 32 volt range. And the terminal blocks, which are removable for aiding installation and service, are able to take a 4 square millimeter cable, which is a 10 AWG cable for those customers in North America. Connecting those in, the terminal blocks have got a screw down cage mechanism, so they're able to accept stranded cables. On this occasion, we've actually put some cord end terminals onto the end of the cable to prevent any fraying. So that's our power supply fitted into the module. So now we have 2 groups of terminals for the output circuits. So working from left to right, we've got channel 1, 2, 3 and 4, and for each channel a positive first and then a negative. The output channels are fitted with terminal blocks that are able to take 2.5 square mil cable, which is 12 AWG for our customers in North America. So that's now the power supply and the circuits connected into the module. What we now have to do is link it to the servo. So the Victron servo gets delivered with a bag of connectors, and I have a bag here. And within that bag are the terminal blocks for digital inputs, power, and the relays. Also included are these 2 CAN bus termination plugs. And each of those plugs is a resistor that is used at either end of the CAN bus circuit to ensure reliable communication. So I'm just going to show how we hook up the Smart Switch to the servo. I'm going to ignore all of the normal terminal blocks, they're all covered in the servo manual, and concentrate only on the CAN bus communication to the Smart Switch module. The connection is made between the modules with an RJ45 patch lead. So on the back of the servo, on the top face here in the center, we have 2 ports for VE CAN. These are the CAN ports that we're going to be using for communicating to the Smart Switch. So the RJ45 goes into one of those ports. And likewise, on the Smart Switch, we have 2 RJ45 ports for the CAN communication, and the other end of the patch lead plugs into either of those 2. In both cases, it doesn't matter which port you use. That's now got the CAN communication cable between the 2 devices. In this instance, the only 2 devices on this CAN network are the Smart Switch and the servo. So we will put a CAN termination resistor into both of these devices. If you had a longer network, then you would need to find basically the 2 ends of that network and insert the CAN resistors at those very ends. So we've got a terminating resistor into the Smart Switch, and now I'll add that into the other CAN port, the other VE CAN port on the servo, and that's now got our CAN communication network complete. To find out where to purchase this unit, just follow the link in the description below.